So hey everyone, welcome to my channel. This is Lakshay here. So today we are gonna start with a new question, that is reverse a linked list, which is a lead code question number 206. So what this question says, it says that we are given a linked list and we have to return the reverse of that linked list. So there will be two approaches to perform this question. First will be iterative and second will be recursive. So we will understand both one by one. First of all, let's start with the iterative. So let's take our example which is already given. So this is our linked list which we have given and we want to reverse it, means we have to make its arrow reverse like this. If we are able to do this, then our list will become reversed. So how can we perform this? We can perform this by simply making two or three variables. With the help of two, three variables, we can simply reverse our linked list. Let's see how. So our head will be pointing here and we will make a current pointer which will be pointing to our current list, and we will make a previous pointer which will be pointing to our previous. In first iteration we will create a temp which will be current next, and then what we'll do next, then our then our current next will point to previous. Our current is this one and which will point to previous, so our connection will be like this, that one will be pointing to here. Okay, clear. Then our previous will move to here on our current, and our current will move to temp, that is here. Okay, so now our connection look like this. Then on next iteration it will same, current will point to here, current will be here, and our temp will be on current next, so our temp will be on current next. Then our current will again point to our previous, so this will point like this, and then our again move to previous here, and our current to here. Okay, so now our links now becomes like this. Now we will simply repeat this procedure again and again. Then our current will move to here, then same it will point to this, and then again our previous move to here, and then our current move to here. Then at the end we will get our desired list. It is. So our final list will look something like that, and hence this is our answer. So let's move to our code directly, which will make it more clear. See, here it is. First of all, we will create a previous pointer which will be pointing our previous, and a current which will be pointing our head. Then look, let me write, previous will be pointing to null and a current will be pointing to head. Then our while loop will start till our current will be null. Then we will create a temporary variable which will be pointing to our current next. Okay, like we said discussed earlier. Let's take again. See, so according to this, our current is pointing here and our temp is pointing here. So what we will do next is our current next. Current next will point to previous, that is this. This one will point to our previous. Our previous is lying here, and that's why it will point to here. Okay, cool. Then our previous will move to current, and then our current will moves to temp. This is how we reverse our first values. Then it will continue, then our current will move to next pointer, then next till we will reach null. And hence we will return our previous, because at the last iteration our current will be pointing to the null and our previous will be pointing to the our head, which is the our reverse linked list. So at last we will return our head, our previous, which will be a new head. So the time complexity for this iteration method will be simple. Time will be big of n, that is time complexity will be big of n, because we are iterating only once to all the loop. So that's it. Let's move to a recursive method. On recursive on recursive method, we will make our head this. Firstly we will given this as head, then we have to go to each node and create it as head, and then check for another node and make it. And while coming back, while recursively coming back, we will change our nodes to again, so that we will get our iteration like this. So let's first write down the pseudocode, then we will jump to it. Okay, so here is our pseudocode for our recursive method. Let's begin. So initially our head will be pointing at 1. See here. So first we will check the condition if head equals to null or head next equals to null. But here we can see heads next is not equals to null, and also our head is not equals to null. That's why we will move to our next step, which says that new nodes equals to reverse. We will again call this function reverse for heads next. Means for this we will again call a reverse function. So when we call a reverse function again, it will again check. Now our head will be this. So now our head will be this. A new head is this. Now it will again check for the function. Then it can again, we can again see that heads null is not, heads next is not equals to null. That's why a new node will again be called here. So now again here will be called our function reverse again. So now we can see that heads null next is equals to null. So we can see that heads next equals to null. That's when we will get our here a new node equals to head. So now we reverse back, we return our value, and now our head is here. Okay, because we have written head from here to here. So now our head is here and our new node is this. New node is this and head is this. So now we have to put our front equals to head next. So our front will be here at head next. Okay, because head is pointing to next, here new node. So now our front next will be pointing to head, so our front next will be pointing to head. Okay, clear? And our head next will be null, means this we will broke this network because it is now point to null. Okay, and at last we will return our new node. So what is a new node? This will be our new head, so we will simply return this. So now our list look something like this. Cool. And our new node is this, and now our head is this. Then again our head next will be, we will declare front as our head next. Okay, then front next will be point to head, and then head next will be null, means we will break this loop because it will point to null. Then again our list will look something like that. One, sorry, point like this. Wait a minute. It will point like this. Okay, so our this is what we got. So it is currently not pointing to anywhere, but now this something looks like this. Okay, so that's it. We will get our desired reverse linked list, and hence we will return our new node. Thus talk about its time complexity, but before that I will provide you the code. So here you can see a recursive code. It says that there is a function named reverse list, which will first check there is a base condition which says that head either should be null, or if heads next equals to null, then we will simply return our head. If not, then we will create a new node which we will get by again calling this function reverse list. where we will pass as a parameter our heads next. Then by all these 3 or 4 instructions, we will get our desired reversed linked list. So the time complexity of this method will same as the recursive iterative method, that is big of n, cause we were iterating only one time, that's why. So thanks for watching. Thank you.